Hi everybody, welcome to another video in trigonometry, section 7.4, area of a triangle. So this is a short section of the whole class. It will be very long if we try to prove all of those area formulas here, but that is beyond what we should do in trigonometry. So that's why we're not going to go over to prove anything. But in the grade school, when we learn about the area of triangle, this is the only formula we have, 1/2 base times height. By the way, we're not going to use A for the area because that might be confusing with angle A, right? So we use K. Of course, we could use something else, but let's use K. Right. So the K, 1/2 base times height. So if that's a triangle, that's what we have. Now, it can be shown that in different cases like angle sine, or angle sine, angle sine, or sine, different scenario, we have different formulas for it. For example, if it is sine angle sine, the formula is 1/2 AB sine C, and of course all the formulas there you can see it. But I just want to prove one of those formulas. Let's put A, B, because that's opposite to sine B, and then C. Here we have the height. Now, what is the sine AB here? I'm sorry. Right. Now, let's say with respect to angle A, we have opposite and hypotenuse. So I will write sine of A is equal to opposite, which is H, over the hypotenuse, which is AB. By the way, the length AB is going to be C, right? So sine of A is equal to H over C. So if we cross multiply, we have H is equal to C times sine of A. Now if we go back to this, we can see that we have C sine A, and what's that? H, right? So C sine A is equal to H, so 1/2 base times height. So the proof for this is easy. The proof for the others are not easy, especially the last one, the Heron formula. By the way, the Heron formula, this formula is more than 2,000 years old. And of course, back in the day, they could prove something like this. But I'm not going to prove it now because it probably take more than one page to prove it, which a lot of trigonometry. Yeah, we only need trigonometry to prove it. But it is beyond what we need. So I'm not going to do that. Same thing for those formulas. Right, so we're just going to use it. So, idea here is just when we look at the problem, we just need to know that what scenarios we have and then what formula we use. That's it, right? So, first example, find the area of the triangle ABC if A plus B plus A, B, C is that. By the way, since we know three sides, this is sine scenarios. That means we have to use the Heron formula. So Heron formula involves knowing S. So that's why we don't want to use S as the area either, because we define S to be the semi-parameter, which would mean half of the parameters. So first S is equal to half of the parameters, little a plus little b plus little c divided by 3. 5 plus 7 plus 8 divided by 3. So that is 20 over 3. So that is the semi-parameters. Half of the parameters of a triangle. Simple enough, right? If I make that 9, that would be a lot easier, but that's okay. Right. Then the Heron formula, because this is the sine scenario where we have all three sides, square root of s minus a, s minus b, s minus c. So we just have 20 over 3 minus a, 20 over 3 minus b, and 20 over 3 minus c. Just put in a calculator, and that's it. over 3. By the way, it would be better if I just do this 20 over 3. Let's throw that into some letter that I can use. Let's say s. Yeah. So square root of s, alpha s times s minus 5 s minus 7 s minus 8, which is square root, so it's 2 over that. Actually, this one should be 2 over 9. Sorry, 20 over 9. So that's what we have. Simple enough, right? Straightforward. So when we have all three sides, that's what we use. Right. Next, an application from Bermuda Triangle. Is that find the area of it if from Fort Lauderdale, Florida, or Miami, close enough, which is here, to San Juan, and to what is the other point? Bermuda, right? So the angle between them is 67 degrees. Live side from Fort Lauderdale to Bermuda and to that. Because when we talk live side, it's not really live side. We cannot see about 1,000 miles away. But yeah, the angle in between 67 degrees from Fort Lauderdale, which is I think close enough to Miami here. And then the distance from Fort Lauderdale to Bermuda is 1,026 miles. And the distance from Fort Lauderdale to San Juan is 1046. And we asked to find the area. So obviously in this case we have the sine, and an angle. So sine, and angle is easy. So we 1/2 AB sine C. And they'll say what is A, what is B, and what is C. Well, it doesn't matter. We have two sides and we have an angle, so we just go ahead and use it. But notice that in this formula, whatever this is the angle between these two sides. Or we just say included angle, which means the angle in between the two sides, the two known sides. By the way, here we have two sides and an angle. Just go ahead and use that, but don't just jump into conclusion. If the angle is here, we cannot do that. We can use this because in this case we do have the angle between the two sides. In the formulas, that formula works if the angle is between the two sides. If we're not sure, we can always assign in the letters, right? So let's say this is angle C. Let's say that is A, that is B. So in that case, this is going to be little a because opposite to A, and this is B because that opposite to B. So in that we have AB sine C. right? If you're not sure, put in the letters. But since we have the angle between the two sides, we're just going to use it. Right. Make sure in the degree mode. The only thing we need. Right. 1/2 or 0.5 times 1026, 1046, and then sine of 67 degrees. It is in degrees. Yep. So we have 493,941 miles on each side. So this is square miles. Right. So that's what we do. Yeah, the actual area might be a little bit different because the Earth is not flat, so it's not a triangle. It's more like a curve. It's part of a triangle, so it will be a little bit different. But that's what we have here, and that's all I want to do in this section. As always, thank you for watching. See you in another video in trigonometry.